Okay, so this is a 6-4 video over rectangles, which is our second parallelogram that we're going to study. Okay, so the definition of a rectangle is a parallelogram with 4 right angles. So if you guys remember, we did have a property of our parallelograms where it said if there is 1 right angle, then that means that there are 4. So with that, that is a definition of a rectangle. Okay, so a rectangle is a parallelogram, meaning all of the properties that we studied with parallelograms are still true. So if you look at our list, opposite sides are both parallel and congruent. That was a parallelogram, right? Right here, by definition, all 4 angles are right angles. Opposite angles are congruent, so that's still true. In this case, they're just all right angles. Consecutive angles are still supplementary. Diagonals still bisect each other. Okay? The only new property is that now our diagonals are also congruent, meaning as a whole. Okay, in parallelograms, they bisected each other, making congruent parts, but now each diagonal is congruent to each other as a whole. So you can also highlight this because it is new and it only, applies to rectangles. But everything else still applies from parallelograms. Okay, so here in this figure below, it says list all the congruent segments, so we can do our opposite sides are congruent. So if I start with AB, AB would be congruent to DC, that's the opposite side. And then if I did this set of sides, AD is congruent to BC. Okay, so those are my 2 sets of opposite sides. I can do each diagonal, right, because now diagonals are congruent. So if I did the diagonals as a whole, AC is congruent to DB. So both of the diagonals are now congruent. And then I can still list all of the equal parts, right? Diagonals bisect each other, meaning AO is congruent to OC. And DO is congruent to OB. Okay, so those are my congruent segments in this figure. All of the congruent interior angles, okay, inside angles, right? So I know that the opposite angles are congruent and consecutive angles are supplementary, right? With a rectangle, they're all 4 equal to 90 degrees, right? So all of angle A, right? Angle A is congruent to angle B, which is also congruent to angle C, which is also congruent to angle D, right? All 4 of my right angles. I can get even more specific because a rectangle is a parallelogram, and we talked about this before, that parallel sides form alternate interior angles. So I can also list my alternate interior angles. What we don't want to get confused with, angle 1 is not congruent to angle 2. Okay, these diagonals are not bisecting these angles. They're just adding up to equal a right angle. They're complementary. But 1 is not congruent to 2. Okay, if I listed out my congruent angles that are alternate interior, 2 would be alternate interior to 6. Okay, so angle 2 is congruent to 6. Angle 3 would be alternate interior to 7 down here. Those are the 2 alternate interior angles with these 2 sides being parallel and DB being my first transversal. Now if I rotated my paper, okay, these 2 sides are also parallel and AC is also a transversal, making 1 alternate interior to 5, right? 1 and 5 are alternate interior angles. So angle 1 is congruent to angle 5. And the last set from these 2 parallel lines and this transversal would be 8. 8 is alternate interior to angle 4. Okay, so those are my my interior angles that are congruent. I could also list, AOB, DOC, those are vertical, and then AOD, COB, those are also vertical. You have vertical angles right here as well. So just make sure you're understanding that there is multiple relationships with the interior angles in a rectangle, a parallelogram, whichever it is. Complementary angles, okay, so now angle 1 plus angle 2 is equal to 90, right? These two angles form this right angle at A. Angle 3 and 4, those add together to equal 90, right? They form the right angle at B. Angle 5 and 6 are complementary. They add together to equal 90. And then 7 and 8 are complementary. They add together to equal to 90. Okay, remember complementary means adds to 90 degrees. Okay, so our first example, quadrilateral RWTS is a rectangle, so we know all these properties to be true. RZ, which is from here to here, is 2x plus 5, okay? SW, which is the entire diagonal, okay, SW is the entire diagonal, is 5x minus 20. We want to find x, SZ, and RT. So rectangles, right, we had a new property that diagonals are congruent. So my two diagonals are RT, right, this entire diagonal, and SW. So I know that these two are congruent. And here is SW, 5x minus 20. Okay, so I'm going to set RT, right, we don't know what RT is yet, but it's going to be equal to 5x minus 20, because if this is 1, then it's also equal to this diagonal right here. We also know that diagonals bisect each other. So this part that's 2x plus 5 is congruent to ZT, right? They bisect each other, making two congruent parts. So this could also be labeled 2x plus 5. So if I'm looking at RT as a whole, right? RT as a whole is 2x plus 5 and 2x plus 5. Or 4x plus 10. So that's one way that I can name RT is by adding these two parts together or just multiplying this by 2 because it's two equal parts. Now to solve for x, I would get my variables on one side. So 10 is equal to x minus 20, add over 20, x is equal to 30. Okay, there's x. They also want us to solve for SZ. Okay, if my diagonals are congruent and they're also bisected, that means these are all equivalent to 2x plus 5, all of them. Okay, so x is 30, SZ is 2x plus 5, or 2 times 30 plus 5, so SZ is equal to 65. RT is the entire diagonal, right? So we could, again, add together 65 and 65, right? Because this is 65, meaning this is 65, and I get 130. Or I could have plugged in x back in over here. 4 times 30 is 110, or I'm sorry, 120, plus 10 makes 130. Okay, example 2, ABCD is a rectangle. AB, this side is equal to 13. Remember, opposite sides are congruent. AB is opposite to DC, so that means that side DC is also 13. BC is equal to 9, and BC is opposite of AD. Okay, remember there are 4 right angles. Okay, find the length of diagonal DB. Okay, DB. Look at what this diagonal DB, the side BC, and the side DC create, or even DB with AD and AB. We have a right triangle here, right? There's 4 right angles. So this diagonal, this side, and this side form a right triangle, right? I'll draw it out here. Here's point D, here's point B, here's point C. We had side BC, and we had side DC. So they want to know, what is DB? Well, for right triangles, if I'm missing a side, I can just use Pythagorean theorem. Okay, so I'm going to take 9 squared plus 13 squared is equal to x squared. 81 plus 169 is equal to x squared. All right, when I add together 81 and 169, I get 250 is equal to x squared. Okay, and if I just want x, right, I have to take the square root of 250. All right, so remember we are not simplifying radicals just yet, so I can leave it as a decimal. Oops, so second square root, 250, 1 second. That's not right. Okay, so I can leave it as the square root of 250, right, if I wanted to leave it in radical form, or as a decimal, that is approximately 15.8. Okay, the square root of 250, which, oh, I was pressing the wrong button. That might help. The square root of 250, 15.8. There we go. So with rectangles, since we have 4 right angles, we can use Pythagorean theorem to solve. Okay, example 3, quadrilateral DGFE is a rectangle. If the measure of angle DEG right here is 9x minus 6 and angle GEF right here is 2x plus 8, solve for x. In a rectangle, we know that there's right angles at my vertices. So these two angles are adding together to equal 90, right? They're complementary angles. So in order to solve for x, I need to take my two parts of my right angle, 9x minus 6, add it to the other part, 2x plus 8, and set it equal to 90, right? They're complementary angles. So this is 11x plus 2 is equal to 90. If I subtract 2, 11x is equal to 88. Divide by 11, x is equal to 8. So there's x, right? They also want us to solve for angle EGF. So EGF is right here. That is not all of angle G, right? That's just one part of it. So we have to go back to thinking about our alternate interior angles. We need to figure out which part is it congruent to, okay? So if I look at the 2x plus 8, I can already tell that 2x plus 8 is going to be alternate interior to this up here along this diagonal with these two parallel sides, right? 2x plus 8 is congruent to this part. Meaning, with these two parallel sides and the transversal, 9x minus 6 would be congruent to this part right here, the part that I want. So I need to figure out what is 9 times x minus 6. So the measure of angle EGF would be equal to 9x minus 6, which is 9 times 8 minus 6. Okay, so that's 72 minus 6, or 66 degrees. Okay, I'm going to stop the video right here, and then on part 2, I'm going to do example 4, just because I'm going to run out of time. But example 4 in part 2 video.